Hello everyone, myself Prechnayak. My teammates are Avinash and Mohan Sai. Our project is driver drowsiness detection using machine learning, and this whole project is supervised by Dr. O.S. Jannat Nisha ma'am. Agenda. This is the agenda of the project. Abstract. Nowadays, more and more accidents are occurring because of the drowsiness of the driver. Driver fatigue has become the direct cause for many accidents that are caused due to the driver drowsiness. Therefore, there is a need to develop the system that will detect and notify the driver about his bad fatigue condition, which could significantly reduce the number of accidents that are occurring due to drowsiness. However, during the development of such system, we have encountered many difficulties that are related to fast and proper recognition of driver symptoms. One of the technical possibility to implement this type of detection system is by using the vision based approach. In this vision based approach, we use eye tracking of the driver and detect the drowsiness. Aim of the project. The main aim of the project is to design a system to detect driver drowsiness by continuously monitoring facial expressions of driver. Scope of the project. The scope of the project is to reduce the accidents caused due to the drowsiness of the driver. Introduction. Driver drowsiness detection is a technology that is used in automobiles to prevent accidents that are caused due to drowsiness. Various studies have suggested that overall 20% of the road accidents are related to drowsiness, up to 50% on certain roads. So, driver fatigue has become the significant factors in large number of vehicle accidents. Recent statistics estimate that overall 1200 deaths and 76,000 injuries are occurring that are related to fatigue of the driver. The development of these type of technologies is a major challenge to prevent the accidents that are occurring due to the drowsiness. Methodologies. We are having three types of modules in this project. Module 1, data collection and training using machine learning algorithms. Module 2, training and testing the model. Module 3, capturing face and detecting drowsiness. Architecture diagram. First, the dataset is collected, is trained by using the CNN model, and then it is classified with the help of CNN classifier. Then the camera will detect the face of the driver, which track the eye of the driver. If the recorded value is greater than the threshold value, it will state that the driver is in drowsiness state, and it will ring the alarm which alert the driver. Data flow diagram of the project. First, initially the collection of data is takes place. After that, we pre-process the data, and then we create a perfect data, and then we apply machine learning algorithm. After that, training the data is done. After that, testing the data is done, and then finally we'll get the output. This is the ER diagram of our project. After that, we are going to the implementation part of the project.
Coming to the implementation part of the project, as we are using machine learning, we need dataset for the project. So the dataset is I dataset, which is taken from the MRLI's website. These are the 37 folders of 37 members datasets with different lightning conditions. Coming to the coding part of this project, we are using Anaconda's Jupyter Notebook. It is a Python software tool which is used for machine learning projects. Here, this is the environment we have created. In this, we are having our notebook. Clicking on launch. The Jupyter Notebook is launched. Preparation module. Yeah, this is the data preparation module. Now here, initially we have to import our libraries, and we have to give the directory of our data set like MRL I data set, and we have to split the data sets into open eyes and closed eyes data set. And for this open eyes we have given the directory, and also for closed eyes we have given the directory, and we have run, and we have splitted. These are all the 37 records we have splitted into 37 open eyes folders and 37 closed file folders. This is the data preparation. Now let's go to next module. Training model. So this is the training module. For this we are importing TensorFlow and TensorFlow library, and we are assigning the train data gen as image data generator, and we are assigning the directories of train data and test data. So we are getting here 64,000 plus images for the train data and 16,000 plus images for validation data. For test data we have 4,500 plus images which are belongs to two classes, and the size of this image, which is length and breadth, as 80 by 80, and the class mode is categorical, and this data is stored in this which is present in this test data folder. Now here we are using modeling. Inception v3 is a modeling technique which is used, which is highly accurate and has less loss. And here we are assigning the layers and training, and model.summary, which gives the whole summary of the model. Next we are importing some of the packages: model checkpoint, early stopping, reduce LR on plateau. These are some of the packages from TensorFlow. Now we are using checkpoint and some directories mentioned here, which is the directory of the file which is stored as model. In model.h5 our model is stored, and this is the learning rate. For this learning rate we are using this reduce LR on plateau. Next this is model.compile. Using optimizer we can calculate the accuracy metrics loss. Next we are fitting the data model data and training the data, using training data, validation data, and we are using epos, like it is like iterations. We are using 5 epos for this, and we are finally calculating the evaluation, like calculating accuracy and loss of the different data we are using, that is train data, validation data, test data. So for train data we are getting the loss as 0.14 and accuracy as 0.94, which is pretty good. And next For validation data, we are getting accuracy as 0.92 and loss as 0.19, which is also good. Next is accurate evaluation of test data. Till here we have completed model training. So let us see where the model is stored. So here my directory is, so here the model is stored. Now let us go to the main program for this project, which is used to capture our face and detect the eyes and calculate the values, score value, which will help us to detect whether the particular expression is drowsy or not. So for this we are importing CV2 library and TensorFlow, NumPy as NP, and Pygame. These are the libraries we are importing, and in this we are using face cascade, detecting the face using CV2, and eye cascade, which is used for detecting the eye of a particular face, and the model equal to load model, which is used to load model which is trained before. Next we are assigning sound, which is alarm.wave. So next we are starting the video capture. So cvt.video capture is used to start the video capture, and we are assigning initially the score as 0. When it is true, then it starts capturing the video and starts and captures the frames and converts the frames into gray color, which is RGB. RGB is nothing but the general images to gray. Gray is which is mentioned here. So face cascade dot detect multiscale, which is this function is used for detecting the gray face, and in the similar way it will detect the eyes. And cv2 dot rectangle means it is like giving length and breadth of the face frame. In faces we are calculating the length, breadth and color and thickness. So these are the pre-processing steps which are mentioned here. And resizing of eye, that is 80 by 80, which we initialized before, and we have to reshape that. This is length, breadth and thickness of that image. So pre-processing is done. Now model prediction. Now we are predicting that eye, using that model we are predicting whether the eye is closed or open. Now if the eye is closed, the threshold value we are giving for closing the eye is 0.30. If the prediction is greater than this threshold value, we will predict that eye is closed, and we will increase the score for every second by second. And if the score is greater than 15, then play the sound alarm and alert the driver. And if the prediction for like opening the eye is greater than 0.90, then we will predict that eye is open, and the score which is increased before will be reducing one by one, step by step. This is the coding part. Now let us execute this project. So now we are going to this execution part. We can use in kernel restart and run all. means we can restart the kernel and run from beginning. So we can see the star marks here, which are representing that it is running. Okay, first cell is completed its execution, second is completed its execution. Now third cell is about to complete its execution. So we can see here, here we can see a new window is opened. Now here it is mentioned that open score and closed score is mentioned here. Now open score is initially 0. Now if I am closing the score increase and the score is decreasing, and gradually the alarm will stop buzzing. This is the whole project. Thank you.